Hello friends, today we will start our topic in mathematics, differentiation. So you have studied already something differentiation in class 11th also. Over here I am going to tell you what is differentiation. What is differentiation? So let's start with two axes, x-axis and y-axis. Suppose we have any function fx, whatever type of function, it may be linear function, it may be cubic function, it may be quadratic function, whatever function is there. So I'm going to start with, suppose 2x square plus of 5. This is the function, and if we want to draw the graph for this function, it will be something like this. Now the question is how to calculate the differentiation of this function. Whether it's a function or not, that is not the topic of our, but differentiation directly we'll calculate of this one. As you must have studied in class 11th, the first principal method. First principal method is also known as ab initio method. Ab initio method. Ab initio method means we are going to start from the beginning. From the beginning, what is that? So just using this one, as you did already, suppose we are taking any 2 points on the graph. Suppose this is the first point, say x1. Any other point on the graph we are taking, suppose this is x2. So x1 and x2 are okay. Now this graph at x1 must be having some value on y-axis. Let this is y1, and at x2 suppose this graph is having its value as y2. Clear? So if we are going to join this point, let this point is A, this point is B. If we are going to join A to B, we will get a line. Again I am going to draw a perpendicular from A to this line, perpendicular. Suppose this point is C point. Now what do we get? A ABC, a triangle. This triangle is right angle triangle, and from the very much observation you can see this graph and this line AB is approximately the same, means their length will remain the same. Now what is the value? You know, as soon as we will change little bit value of x, obviously the value of fx will also get changed. That means if we are taking the value of x at a particular thing, suppose 2, x is equal to 2. So the value of fx will be 2 square plus of 5, which is equal to 4 the 2 to the 4 to the 8 and 5, 13. By chance if we are going to change the value from 2 to 3, so it becomes f3 will be 3 square plus of 5, which is 3 there is a 9 to the 18 and 18 and 5 23. So when there is a change in x, there is a change in y also. What is the change in y axis? That is called BC. So BC is the change in the value of y when the change BC, this means x1 x2 is the change in the value of x. This is the change in the value of x, and this is the change in the value of y from x1 to x2. Now suppose this angle between AB and BC, AB and AC is theta. Then we know already how to calculate the differentiation. What is the differentiation actually means? The differentiation actually means we have to calculate the slope. What is the slope of that curve at a particular point? So what is that? as usual we did earlier, we are going to calculate tan theta, and tan theta will be the slope of any curve. Slope of any curve. How to calculate tan theta? We know what is the value of BC. BC will be equals to, this value is y2 complete, y2, and this value is y1. In the same way, from here to this side, this value is x2 and the value of this one will remain x1. So the middle value, this one, will remains x2 minus x1, and the value of BC will remains y2 minus of y1. It's okay? y2 minus y1, x2 minus x1. Now what we have to calculate? Tan theta. As tan theta, you know, this is perpendicular upon base. What is perpendicular over here? y2 minus y1 divided by x2 minus x1. This is called the slope, and this is the value of fx. We can write fx plus h minus of the initial value fx divided by change in x, which is also known as fx plus h minus of fx divided by h. But what is h over here? H is the distance between the x1 and x2, very minute, means as we please, as equal to 0, but not exactly equal to 0, approximately equal to 0. So what we are going to write over here, we are going to write this one, this change in the value of y, which is generally the change in y is known as delta x in x and delta y in the value of y. So what we will write, this one, dy d over dx, or delta x, this is y, change in y is dx, dy, and change in x is dx, which is equal to this, the value of x plus h minus of fx divided by, in the same way, h. But since this h is very very close to this one, very very close to 0, so what we will write, we are taking limit h tends to 0. H is always tends towards 0. So this is the final formula to calculate the differential coefficient or differentiation of any function. This is the function, whichever function we can take it. So using this formula, we can calculate the differentiation of any function. So using this method of finding differentiation, that is called first principle method, we can solve different types of examples. Let's take an example of fx is equal to x to the power n. And in the next lecture, we will start the how to calculate the differentiation of the different type of functions.